All right, guys. Update on the Creatbot. As you can see, it's upright. So I'm going to be turning it back over. So maybe I'll be able to do that in the video and show you what else I have left to do, because I have some other pins I have to coordinate with what they're actually going to be doing. But it is up and running to the degree that from my computer, because I don't have the screen in. Of course, I have to plug in my laptop right now because it died. I haven't had it plugged in, so just give me a moment. Matter of fact, my tablet might work. Where's my iPad? That's starting up already anyways. So I had a couple of questions. People were asking me for a list of materials that I used. It would be a tremendously big list of materials. So I'm just going to tell you, I got a bunch of different wire. I got these spools of wire. So you want to get high temperature wire. Those are rated for high temperature, and those are, I think this is 20 gauge. It doesn't say right here, but I ordered 2 spools of them because I'll use them for other projects as well. So on the brand new spools it says, yeah, it's 20 gauge, and it's high temperature resistant, and obviously I got a lot of wire, and there's more up here. So lots of wire, and you definitely need these, a kit of these. Those are the type of connectors that you need, and the pins, and you need the crimper to crimp those pins. I'll show you in just a second, as soon as I can find it. The crimper for those pins is somewhere around here. It's been kind of a mess since I've been doing this project because it's been really consuming me, and I haven't been like cleaning it up at the end of the day, because guess what? I was coming back to do more the next day, so what was the point, right? Here we go. And a wire stripper like this. A wire stripper like this for sure. Let's see. A wire stripper like this. A crimper like this for those fittings, a ratcheting crimper. You'll definitely be glad that you got one of these for ratchet straps. It tightens ratchet straps for your cable management, which you'll see I went to great lengths on mine when I turn it over. Heat shielding. This is for the thinner wires and for the liquid cooling. So I got this on Amazon. This is silicone fiberglass, something black 5/16, and these are 24 feet each. I went through, this is the second one, and I didn't use that much of it, but you need more than one. And if you're going to do all the wiring like I did, this was the tool head sheathing for all the wires going to the tool head. This is very high temperature. I put a MAP gas torch to this, and it wouldn't ignite. It wouldn't even melt. So I didn't hold it to it for an extreme amount of time, but I did hold it to it. And the printer is definitely on. It's homing X and Y right now because I'm still configuring the beacon, but I wanted you to at least see it move. Okay, just about there. Let's get this reconnected because the computer was just off. It'll connect to Clipper. I'll show you this too. So that's my computer screen, and you'll see it's connected to Clipper. I have the printer config file like a lot of the way done. So home all, it's going to move. You see it's starting to home X and Y. And then it goes to somewhat the center. I have to adjust that a little bit. But it's going to say right here, in red right there, no beacon mode 1 loaded. So I have to work on the printer.config file a little bit more for the beacon. I have to work on it a little bit more for the other parts of the printer config that's not loaded in here, that are not actively working yet. And there's a few things that I have to still do, so it's not quite done. But I do want to show you underneath, because I need to get back under here anyway. And it's not that easy because it's hooked up to water lines for the water cooling, and it's not very light. As you can see, it's a whole steel frame and steel enclosure, other than the PC windows. This is a good 150 pounds, so it's not easy to move around, but Now you can see my yeah, I'm not done with the cable management, but I've done a lot of it. So over by the board where I'm still working a little bit, it's done, but I'll show you what I went through. So these are two SSRs. These are for the 120 volt that goes to the bed and to the original chamber heater. And then I added those 4 more chamber heaters. This is a 24 volt MOSFET for those. And then the cooling, I did a turbo fan that widens the path, and it goes by these. One fan going down on the MOSFET, one going towards these MOSFETs and going all the way out this way. On this side, I have one fan going towards the board, one on the board, and one up here sucking everything out. So it goes this way on this side and this way on that side. This is my second power source. I got a 450 watt Meanwell, and it died when I was programming with that kit I was telling you about. So, well, I'm sorry, that was in the other video. But anyways, it died during trying to get some help with the clipper, which it wasn't a whole lot of help because I had most of the stuff done, and all we did was find a couple things that I had to fix, and then I spent most of the time fixing them. And then he was supposed to call me back today, and the day's over, business hours, and he hasn't called. So obviously that was very professional. So I'm just doing it myself at this point. I'm not counting on anybody else. I've definitely learned enough researching all this stuff to be able to finish this myself. So that's what I'm going to do. But if any of you guys need a hand, I actually will call you, and I actually will, keep my word when I say I'm going to call. And I'm happy to help people out. That's why I do these videos. But this is a E3EZ main board with 2209 drivers. I did get two 5160 drivers for the super speed X and Y axis. I didn't put them in because I didn't. This was a configuration that I already had. I may end up doing that later, but this is an adjustable 600 watt power supply. So I have it giving 24.6 volts. This will go up to 36, but I also have another power supply coming in that's 1200 watts. So I'm giving it a lot of power because it needs a lot of power. All the heating sources that I have in here and all the electronics, it's going to need a lot of power. And if I add anything to it later, it's going to need even more. And this doesn't even support which now I probably could use another MOSFET and go right 24 volt to the liquid cooling, which I very well may do. I actually have another 24 volt MOSFET. I think I'm going to put that in right over here and put a little bit more cooling for it and have that be triggered by this on one of the open pins, and then have the liquid cooling kick on whenever I'm going over a certain temperature. So those are other things that I need to figure out how to configure, but motion is working, the homing is working, the limit switches are working. I've gotten a good amount of the way. I should be printing within 24 to 48 hours at the most. So I'm looking very much forward to that. I'm looking very much forward to sharing that with you guys. So hopefully you are too, and you can tune back in. But this MOSFET was, here, I'll show you. I'll pull up my Amazon history so you guys can see exactly what I bought. Which, like I said to the gentleman who asked me what I had bought, it's so much stuff that I wouldn't have you guys buy all of it because I didn't use all of it. So here's one of the power supplies. This is the one that's still coming in, I believe. That's a 1200 watts. No, this is the replacement for the 450 Meanwell. And that one says it's coming tomorrow. And then I have, this is one, I don't remember what this is one that was pretty expensive. It was like $100 and something. Yeah, this is 1,000 watt. It was $100. And then I have so many purchases on here for both work and personal. Let's see. And then limit switches. I prefer these type of limit switches with the rollers. Those are a little more precise. So I use those. And this is the ones that I have right here. I got a bunch of them in case I need to replace them or use them on something else, but they look like that. And then what your end limit stop will go and up against that roller, so it gives it a little bit more precision. rather than just like a standard one like this that just has a little plate trigger. They're just higher quality, more precise, and they work great. And then the screen, I have like 4 screens. I still have to decide which one I'm going to use. So when I do, I'll let you know. But you know, any Raspberry Pi display that connects to your setup, whatever kind of setup you have, this is the power supply that I have in there now. And Meanwhile is a very reputable power supply manufacturer. So I think it was just a fluke that I got the bad one. I don't blame them. It must be one of those things. You know, they make a ton of products and sell a ton of products. So here's the MOSFETs that I got. That's the MOSFET right there for the 24 volt. And then I'll show you the SSR for the 120. So I got 2 of those. I have 1 more. Let me get back to that. And then show you the SSR that was right around there. All right, here's the SSR. It's called an Inkbird SSR, solid state relay. That's the this is the page for it right here. They're 40 amp, and the 24 volts are also 40 amp. So that I got high amperage and high, that most people probably don't use all of, but I'm using a full 40 amps on this. And on these, I'm not exactly sure how much I'm using because that's the original stuff, but I'm using more than they were because my temperature limits are 200 on the bed, 180 in the chamber, 500 on the hot end. So I'm using a lot more power than they were. And then these are for other projects that I had going on. There's the high temperature silicone. Those are I used it for the liquid cooling, sheathing for over the hoses in the chamber. Even though I used high temperature Capricorn tubing, I still had it wrapped in high temperature everything because it's got liquid in it and it's going through my printer, so I didn't want it to melt in there. And then I got filament runout sensors because I didn't know if mine were going to work, but mine did work. And then the filter right there, that's this right here. I replaced the original filter. That's the other set of silicone I had to get. There's all the wire. That's an RPM gauge I got for something else. So a couple pentanometers I didn't end up needing. Some liquid cooling blocks, which I ended up machining my own. There's the connectors. I used all metal connectors in and anywhere near the chamber. Then these are some of the stepper motors. I used LDO NEMA 17. These are some of the insulation. Like this insulation was really good. This is the one I preferred the most, that I used the most. This is supposed to be resistant up to 2,900 degrees. So obviously it's a very substantial insulation. The metallic surface is supposed to be resistant to that temperature. This one is doing pretty good at 600 watts. I'm going to decide once I get the 1,000 and 1,200 watt ones that I have coming, which one I'm going to end up using in this printer. I may go with the 1,000, I may go with the 1,200, I don't know, but this one is adjustable, so I could always use it for an extra benchtop power supply. And then I also got one of those tools to remove the pins if you put them in wrong into these connectors without having to cut them or break them. That's going to be worth its money because all the times you have to change connectors. And then every time I click on it, I lose my place and I have to go back through it all again. So I'm trying to show you from here. And these are reducers, metal reducers. Those go from the 6mm tubing to the 4mm tubing that's in the printer, which is the Capricorn high temperature tubing, which I'll show you in a minute. I also got this temperature thermocouple because it's right here. Because those small temperature gauges can't take the temperature of this. It's going to be too hot. So they stop working around like less than 100 C. So this one has 2 probes that go in, and this can do up to 3,000 degrees. So that'll be plenty sufficient to take the temperature in here. And I lost my place again. I got to stop doing that. So hold on. Then further into my material list, there was more insulation. It wasn't just that one kind. I used some of the foam stuff where I could on the bottom where there was more space because it's a little thicker. It's actually substantially thicker. Some elbow fittings, but you see all steel fittings, no plastic. And then some other cooling blocks those are for the stepper motors themselves to cool them. And what other? Then some. There was some other like heat throats that I got, and let's see what else. I got a bunch of stuff that I ended up returning because I could only use so much of it. But there's the E3 EZ board that I used, and the steppers. I ordered 2 of the board to have a backup if I blew one. And these are the heaters that I used. I used 2 of these. And then I used 2, I bought more than I needed, like I did with everything. And then these are, I had gotten like 6 or 8 of those and I only needed 2. So I kept an extra one in case one blows and I sent the rest back. Let's see, what else did I get for this? So the crimp fittings that I was telling you about, you know, the different size fittings you're gonna need for whatever board you get is probably gonna have different connectors. Make sure you get the right ones for your board. This is just the vacuum chamber that I got for drying out filament. And there's a lot more. I got a lot of stuff from other places other than Amazon too. Like the Raspberry Pi 4, CM4. Computer module 4. I got that from another place, Pittsburgh, I think it was, Supply or something. And I got the LDO motors, other than the 1 or 2 that was available there. I got those from LDO themselves. This one string is stuck here. I don't want that to mess the print up, so I'm going to get rid of it. Oh, I guess 2 strings. Let's try to get that off clean. All right. All right, let's let that keep doing its thing. Oh, sorry, that's not for this video. Anyways, I had to check on that. But so anyways, you see, I've taken a lot of time to be meticulous and get this done correctly. I still have some programming to do, and some, you know, doing it on my own is taking longer because, you know, this is my first 3D printer build. Although I do know a lot about CNC machines and all that, so I had some experience that helped me out, but not as much as I would have liked. But anyways, and then a good idea is to do something like this. This is a pinout of the board, and then I actually labeled everything how I put it on what pins and the pin numbers and everything, so that you can go refer back to this when you're doing your printer.config file. If anybody doesn't know how to do the printer.config file, matter of fact, I'm working on mine right now in the other room, so I can show you. I'll bring you to my desk over here, and I'll show you where I am right now. I was just eating lunch. Let me just clear off my desk. I know I'm such a healthy eater, but I'm an on-the-go eater. Okay, so here's I have my 3 screens open. This is my printer config file over here. I'll zoom you in a little bit so you can see it better. Okay, so there's my printer config file, and then on this middle screen I have the clipper stuff for you know what you're supposed to have in here, and I'm just making sure that I have everything correctly, because what I'm getting is that the Z isn't moving because it's not getting the beacon thing. So once I get that, I should be able to home all 3 axes. Once I can do that, then I can move on to, you know, the rest of the pins that I haven't programmed, where I have stuff installed, what it is, you know, the 2 runout sensors, the second extruder, all that kind of stuff. I have to put a pin code in here. I have a coding in for here for the second extruder, and I'm not probably going to keep both. I'm probably going to custom design a tool head mount for only one of them. In the meantime, I put them both on there because I used the original one, which I had to modify it so much I may as well have just made my own. But I had to modify it for the end stop. For both end stops. I had to modify it for both extruders because they mounted completely different. One mounted to the front, and then one mounted to the bottom, but in a totally different location with a new hole for the filament because it was way smaller, and a new set screw. It was just, I did so much on that, I may as well have just designed one and CNC cut it, but I didn't, but I'm gonna end up doing it anyways because I'll probably keep just one extruder. And then I also have this idea to, so I have a liquid cooled extruder, right? Oh, those are more limit switches. I have a liquid cooled extruder, but I also have a liquid cooled nozzle that's back in the other room. But to give you an idea on the screens, these are just a few of them, but these are all that are in here that I'm trying to program. Like I literally got a lot of screens to try to find the right one to fit in there right and to work right with it. But I showed you the limit switches, I showed you the wiring, I showed you the wire covering. Fork connectors you're gonna want, I always use heat shrink. I'll show you all the connectors that I have, and I'll show you more particularly which ones I used. So I used these for the fork connectors. These are just heat shrink fork connectors. And then for if I need to do any taps into wires, I use these little ones for smaller gauge wire, and they do 2 wires at a time. Or I use the posi tap if I'm using a bigger wire. And then let's see, these are the limit switches, and then these are just also wire connectors that you can interchange the wires back and forth. And let's see, this is the rest of my wire connector box. Sorry, I hit the button turning the screen. This is my wire connector box, one of them that has a lot of the heat shrink that I use, and I prefer these connectors because these have solder in the middle. Oops, these have solder in the middle, and then glue on either side, and then the heat shrink all the way up. So those are good because the solder melts and you get a really good solid connection where you can use them, because if the wires are, if they have tension, you want to crimp them rather. And for crimping them, there's a few different colors which are different gauges of these type that you crimp them and then you heat shrink them. And then heat shrink, I recommend Wirefly. You can get it on Amazon. It's more expensive than the rest of them, but it's worth it because it's like 3-to-1 or 4-to-1 shrinkage. And when it shrinks, it's got a lot of adhesive and it really works. So honestly, you know, to buy cheap stuff, you get cheap stuff. It's really not worth it because you end up paying twice when you have to do it twice. So anyways, that's my recommendation for most of the parts. The bed leveling sensor, these right here, Beacon. So this is an eddy current bed leveling sensor. You can this takes 1,000 measurements per second, and you can level your bed in like 10 seconds with a very in-depth mesh. So definitely consider Beacon for your bed leveling. I highly consider it. I highly recommend it. And for the extruders, the left side black extruder is a Hextrudort. It's Hextrudort. And I used a couple rings of a spider hot end and a heat throat, and then it's a 7 to 6 millimeter, and then the spider heat block. And then I used the bigger heat block on, that's a BMG all metal hot end that's made for the Intamsys that I had my bad experience with. But I ended up using it, I modified it to fit the way that it is, and I put it in here with some liquid cooling, and then you see my additional heat sources, and there's 2 more on the outside walls. And then this is the liquid cooling system that I built. So I ended up first starting with the small pump on the bottom next to the reservoir, and then now it goes up into the radiator, and now I added this big pump. So this has got some serious flow. And then every time I keep moving the printer, and then this thing pops off. That's why I Velcroed it. But that has a readout for temperature right here. The wheel will spin with flow of water, and then it'll show you the temperature of the water right there. So when I turn it on, when I start using it, I'll have that on. But the board I just cut out behind the radiator so it has some airflow, and I spaced it out from the wall to give it airflow. But I mean, all of it took time, but it's only been a couple weeks and it's come this far. And I think by the next couple days, so shortly over 2 weeks to completely do this. But I dedicated a lot of time to it. Like I have a full-time job. I own 4 companies. I've been doing this in the afternoon, evening, sometimes till 4 or 5 in the morning, and sleeping a few hours. I've been really dedicated to getting this done because I got into it, and when I get into things, I'm kind of dedicated and obsessive, actually, you could probably say safely. So I got into it to that extent. So, and then I had a lot of people rooting me on, like all the way through the gamut. So now I'm even more motivated. So I just kept going, and I got it done, and here it is, and I'm very happy with the result. It's just about there. I'll be even happier when I see it printing peak or peck, but that's going to be very soon. I'm gonna stay with it until it's done, which shouldn't be much longer, and I'm eagerly waiting to see that, and I'm eagerly waiting to show you guys. So stick around. I'll have another clip to this video, and at the end it'll be printing some good high temperature material, or at the very least I'll be doing the test print with something like PC or a high temperature, maybe PPS, a high temperature nylon or carbon fiber. But right now I'm going to get back to work on my printer file, and then I will get you guys back in when I make some more progress and get you seeing that thing printing. All right. So all you guys that have been reaching out, I appreciate you, and any way I can help you guys, I really am happy to do it. I mean, anybody who's contacted me will tell you that I'm very welcoming to help other people out. That's really why I do these videos. I'm not just saying that. I genuinely do it for that reason. So I really will help you out if you reach out. So don't be shy. All right. I'll see you soon, guys. Hey guys. So it's been kind of a long night. I did a short clip of how much progress I had made on the printer last night. And I told you guys I wouldn't come back until it was, the next segment it was going to be printing. And what do you know? I was so close. I just couldn't give up. I had to keep pushing. And I don't even have a part cooling fan on it yet. I need to find one to find a part cooling fan that I can fit on there, because I just made that last night. I just CNC machined all the aluminum and the the brackets for everything. And I had that liquid cooled hot end, and so now there's a liquid cooled hot end and a liquid cooled extruder separately. If you guys can't see, there's a close-up. It's the same extruder. The other one, so that's what it was, why it wasn't working properly, because I guess that being a direct drive, it didn't cool it between the extruder and the hot end enough. But now it's like it's throwing that filament out, like it's throwing a lot of it out. It does need a part cooling fan this is PETG, but high temp filament would probably print really well in it right now. So that's the next thing. This is just like an overhang test. I'm gonna let it finish, and then I'm gonna do some carbon fiber or something, see how that goes. But yeah, it's working great. So I already ordered that Goliath hot end. I mean, I don't know, it's pretty long, and I'm gonna lose an inch or an inch and a half of Z. But I don't really print anything 330 millimeters high anyway, so I mean, it is what it is. But this is printing also, it's not going nearly as fast as I can make it go, but it's going faster than it ever did as a Creatbot. And you see I covered up the spot where the screen used to be and insulated the inside of it. So the new screen is gonna, as long as I get it to work, that's the only part I haven't gotten to work. The camera's working, everything else is working fine. But I'm probably going to mount it right over that part, because it's a 7-inch. So hopefully that'll get done. But other than that, it's printing pretty damn good, and I'm eager to see it print carbon fiber or something that doesn't need part cooling, like PPS. I'll probably try PPS, or maybe I'll do some PA12 or PA6 first, and then I'll do the PPS. But either way, they don't need a lot of part cooling. So I do want to get a part cooling fan on there though, so I'm going to try to look one up, or I might have to design one myself. But finally, we're here. I didn't change the power supply yet. I am going to. I decided to put this one in the 1200 watt, just because with all the heat on at the same time, it's going to take a lot of power. So I may as well give it all I got, and that's the biggest one I got, is the 1200 watts. So I'm going to put that one in there. I actually am still contemplating, because that one is a fixed. That one is a fixed. It's not adjustable, and then I have the one underneath here now is adjustable, and I have it set to 24 volts or 25 or something like that. But the this one here can go up to 48, but it's the main thing is that it's 1,000 watts, and that was a really good quality power source. It was the power supply. It was expensive. It was like more than any of the other ones, even the 1,200 watt. So I was thinking about putting that one under there, but that one's adjustable. I mean, it doesn't really, I don't know. I'm just happy that it's printing so that I don't have to focus so much energy on it now. So anyways, mission accomplished. I mean, there's still some tuning to do. There's still, some odds and ends, get the screen working, decide on the other hot end with, do I keep it? Do I send it back? Do I put it on and see? I mean, if this is still, if this performs the way it looks like it's going to, then I don't see any reason to use it. I mean, it seems like it would have a lot of flow. I'm sure it probably does, but this is having a crazy amount of flow already. I don't think it needs to go any faster. I mean, the filament does not need to come out any faster. I haven't increased the amount of filament coming out of it. I haven't had to. And I had such extrusion problems. I'm surprised that it's working so well, but it really is. So anyways, that's that. It's one for the books. This build is done almost, but it's basically done. Like, focusing on it most of the time is done. That part's done. It's time to just fine tune it and tweak it, but I can actually print with it, and I don't really have to do anything else to it except the cooling fan, which is obviously a minor thing after all that I've done to this printer. But I'm just happy that I'm at that point. So I'll let you guys know how the high temperature stuff goes. Maybe I'll I have a lot of videos that I've done over the past couple weeks that I haven't even put up because I've been so busy. I haven't even edited them because I've been doing this. I've been practicing for shooting competition. I've had a lot of stuff going on, and then I had several things come in that I did box openings for, the laser etching thing that I got, fiber laser, and then another printer that I had come in. Anyways, I had a lot of reviews and a lot of regular videos that I did, and I haven't even edited them and put them up. So I'm gonna work on that today now that this is done. This has been sucking up a lot of my time, really. I did not think this was such a big job. So any of you guys that contacted me, or anybody else that wants to contact me, feel free. But if any of you guys need help, and if excuse me, long night. The people that do have a Creatbot F430 and that want to modify it, I'm happy to help you out. But this somebody asked me about buying my printer config file. I would give it away, but it's not going to work. There's no two printers that, unless you're mass producing them, like Bamboo or QIDI or any of these companies, Creality and all that. If they're mass producing the exact same printer with the exact same parts, every single printer has the exact same parts, so it's going to work on multiple printers. But this is a different thing. I mean, even if you have an F430, I don't have one original part in this machine. The only thing original is the housing and the some of the mechanical parts, but there's not one electronic except the heater and the hot bed. Those are the only electrical components that are still there. And the heater, I just kept it as an additional heat source. I put a lot more of my own and in a better location for the chamber to be like where it's actually printing up top. Anyways, the heat bed was good. It's aluminum and it heats up really quickly and it maintains the heat. Yeah, there's no reason to change that. But I'm happy to help you. Like, I'm happy to show you what I did, because when you buy a board, when you buy a main board, there's going to be a generic configuration that you download for it, and based on the stepper drivers that you're using, if you're using 2209s like I did, and I did get 5160s for the Y and the X. but I didn't end up using them because I just made it easier. And honestly, I don't need it to go crazy fast. It's really an industrial printer. It doesn't need. I did get the LDO super speed motors, but I mean, it's not. I got them more for the torque holding power and all that than I did for the for the speed. I mean, I did want it to be faster than it was, but I wasn't expecting it to be like a race printer. Or like, I mean, it's probably as fast as the Bamboos. Honestly, probably. I don't know. I haven't tested it yet. This is the first time it's printing successfully, and it is printing. It's printing successfully. So I'm eager to see what it's going to do with a higher temp material. I'm going to try that next. So anyways, I mean, usually this thing used to take forever to do that little overhang test. This was a slow printer when you buy it. The way it comes, it's a very slow printer. And the way it's printing now is nothing like the way I first got it. It's kind of impressive. But everything is different. There's nothing, I don't have one stepper motor original, not one wire, not one board, not one anything. Even the USB port is dead right here. That's why I'm going to cover it with the screen. That's dead, these are dead. These are the new USB ports. And that's the new switch. So there's literally nothing original. I mean, you guys have seen in the other parts of the video underneath of it, I ripped everything out. So I'm happy to help you guys. Anybody that has one of these or wants to get one or wants to modify one, if you need some help, I'm happy to respond. I respond to everybody. If you guys have reached out to me, you know that. But so I'm happy to help you out if you have a question or if you have something you want to do and you think I could help you from having experience doing this. I'm not a master 3D printer guy, that's for sure, but I know how to do coding since I was a kid, because when I was a kid, that's all there was DOS. So I still remember from that. I always was good with computers and CNC machines. CNC machines are the same concept. But other than that, I'm not some like wizard with 3D printers. I just decided to do this because I got into the hobby recently. Not that recently. It's probably a year now, but I got into it a while ago, and you know, it's been something that like all the hobbies that I get really involved in, I get all the way involved in, like 110% or not at all. That's how I am with everything in life. So this one was 110%, and luckily it went pretty well, and it's working. So I'm just happy to see it printing. All right, so that's it. If you guys need some help, if you think I can help you, feel free to reach out, and I'm here. All right, have a good one, guys, and this is one for the books. See you later.